Mr. Harris here, and welcome back to another video of Unit 10. In this video, we'll do a quick recap on what we have learned in the previous video, and then we'll do some questions together. Alright, so in the previous video, we talked about three different methods of extracting metal, which would depend on the metal reactivities. So the reactivity of the metals, there's a series that I've shown you on the diagram on the right. Metals that are least reactive or not really reactive, that have low reactivity, are at the bottom of the series. Those that have moderate are in the middle, and those that have high reactivity are on the top. So metals that have low reactivity are those that we would need to heat the metal alone, the metal ore alone, or the metal mineral alone. So this method is for metals that have low reactivity. The second method we've learned is heating with carbon or carbon monoxide. This method is for metals that have moderate reactivity. I'm gonna go ahead and write it down on the diagram. And finally, the last method we learned was electrolysis. So this is for metals that have high reactivity. And these metals are up above the metal reactivity series. So those that have high reactivity. All right. Say, for example, if I want to extract calcium, and if I do methods 1 or 2, will I be able to extract calcium? The answer is no. The only way to extract calcium would be to do electrolysis. So there are no shortcuts for this. Also in the previous video, I talked about the word equations. So you'll also need to keep this in mind when we do the questions. However, before we go, one more thing to introduce. For method number 2, sometimes we call it carbon reduction. Why do we call it carbon reduction? Because first of all, obviously the name is carbon comes from because we're heating it with carbon. The second word, reduction, is due to you're reducing something. For this word equation, you have oxide in the beginning, right, in the reactants. However, after the process, you do not see oxygen in metal anymore, right, in the metal. So oxygen in this case has been reduced, hence why the name is carbon reduction. However, there are some other meanings or implications behind this word reduction, which you will learn in a couple of more chapters later. This is on page 5. Copper is extracted from copper 2 carbonate in a two-step process. So before I even go further, can you tell me how is copper extracted from its ore, from its mineral in this case, copper 2 carbonate? Copper, as you know, is it a highly reactive metal, low or moderate? So if you go back to your table, it is a moderately reactive metal. Hence why the process would be method number 2. Yes, so let's have a look. Method number 2 over here. Copper is over here. So we'll be doing heating it up with either carbon or carbon monoxide. Okay? So let's see. Step 1. Copper 2 carbonate is converted to copper 2 oxide. Step 2. The oxygen is removed from the copper 2 oxide by heating with carbon. There you go. Heating with carbon. Question A1. Describe how copper 2 carbonate is converted to copper 2 oxide. How can we convert the carbonate to oxide? So you can pause the video and do all these questions by yourself. All right, I'm going to go now. Copper 2 carbonate. What if I change copper 2 into something that you're more familiar with? What if I change it to calcium? Calcium carbonate and calcium oxide. I think now you're able to tell me, right, how you can convert calcium carbonate to calcium oxide? Remember you learned this in Unit 4? I told you the whole story Pretty funny story, right? About how calcium carbonate is converted to calcium oxide and the whole process, the cycle. Do you remember? So this step is basically done by heating it up, right? Heating it in air. And the word equation, you should be familiar with it as well. So in this case, you would just need to convert the word equation that you have learned before and remove the name of calcium into copper 2. So let's have a look. So as I mentioned earlier, the answer to A1 is heating it in air. And A2, we've just transformed the original word equation that I've taught you in Unit 4, which is this calcium carbonate. You heat it up in air and you got calcium oxide plus carbon dioxide. So it's the same. Okay? Let's read question B now. Let's go back. Write the word equation for the reaction involved in step 2. So they're asking about the word equation. So you guys should be familiar with the word equation now. I told you to write it on your notebook. So remember, it's metal oxide first. So the metal oxide in this case is copper 2 oxide plus carbon. And then I'm going to heat it up. And then what do I get? I get the metal, which is copper. And what's the other product? Carbon dioxide. So I'm using the word equation that I've taught you for method 2. I'm just applying it over here. So let's have a look at the answer. Copper 2 oxide plus carbon, you get copper plus carbon dioxide. You can ignore the carbon monoxide for now. Just look at carbon dioxide. Oh, you can already see the answer of question 2, but let's go back. What do you call a reaction in which oxygen is removed? Oh, I've just introduced that earlier in the notes. It's carbon reduction, right? So reduction is the answer. Okay, you can either write reduction or carbon reduction, that's fine. Let's do one more. A student heated a mixture of powdered carbon and lead-2 oxide in the setup shown below. Oh, this is a hint. They're telling you they're doing heating with carbon. So method number 2 again. And here's a diagram for that. You can see that a very strong heat is being applied, and you have lead-2 oxide over here and carbon over here. Let's see the question. Question A1. What could be observed inside the crucible at the end of the reaction? So what can you see at the end of the reaction? And in question 2, they're asking to write the word equation for the reaction that occurred. So just imagine, after that you've done this process, you're heating the lead-2 oxide with carbon. What are the products that you get? So what are the products you get? You would get the metal. You would get the metal plus, what was it? Carbon dioxide, right? At the end of the word equation. So let me just write down the word equation again. Metal oxide plus carbon. You would get metal plus the carbon dioxide, right? So what do you observe at the end of the reaction? You would observe that there's a metal being formed, right? So what color is the metal? Lead. What color is lead? And metals tend to be shiny as well, right? So you're going to go ahead and write that down. The metal that you observe is a shiny silvery metal. And in this case, if you know, we all know that it's lead, you go ahead and write that down as well. So you see a shiny silvery metal lead. That's okay. However, if you just write down the answer lead, you would not get any marks because that's not what you observe. You will observe something silvery, something shiny. And the word equation, you write that down by yourself. You will need to change this one into lead, and then this lead 2 oxide, and this one into lead. So it will look something like this. Lead 2 oxide plus carbon, you get lead plus carbon dioxide. Okay, sometimes you can write carbon monoxide, but I prefer you to write carbon dioxide so it's more easier for us to go through the questions together, okay? Because most of the cases, carbon dioxide, if you just write carbon dioxide, that is fine. Let's read question B. Name another substance that can reduce lead-2 oxide to lead. So we need to use another substance that can reduce lead-2 oxide. Method 2. For method 2, we either heat it up with carbon, right? Or what's the other substance? Carbon monoxide. So let's go ahead and see. The other substance that we can use is carbon monoxide. Question C. The student repeated the experiment by using aluminum oxide instead of lead-2 oxide. So using aluminum oxide instead of lead-2 oxide. State and explain the expected result. Now, we need to consider this metal. What's this metal? Aluminium. For aluminium, is it a highly reactive, moderately reactive, or lowly reactive metal? So let's look at the table. So if you look at the table, aluminium is on the top over here. It's a highly reactive metal. And the only way to extract this would be using electrolysis. Okay, keeping this in mind, in this question, in this experiment, what process were they using? Yes, they were using method number 2, heating with carbon. So can we use this method, heating with carbon, to extract aluminium? The answer is no. And why is that the case? Because aluminum oxide can only be extracted by electrolysis due to it being a highly reactive metal. Okay, so no reaction would occur. Nothing would happen because the carbon cannot remove oxygen from the aluminum oxide, meaning there's no reaction. Basically, nothing could happen. The aluminum is highly reactive. You can only do electrolysis. All right. So this is a summary of how you could extract metals from its ore. The 3 methods, I repeat: heating the metal alone for those that have low reactivity, heating with carbon or carbon dioxide for those that have moderate reactivity, and finally, electrolysis is for those metals that have high reactivity. All right, so that's the end of this video. I'll see you in the next one. Bye.